Hello there. The purpose of this video is to give you a very brief overview of how we go about setting up autonomous RF, in this case on Velox 3.4. This is a prototype version, but will be quite similar to your use of Velox 3.3 should you be using that. That's a current release version. In conjunction with WinCal XC, in this case version 4.9.10, I believe. We're using a wafer from FormFactor. It looks very much like an ISS in a way, so not to be confused with it. And we're using, we've got 110 GHz probes. In this case, we're using the 104783A impedance standard substrate. So I'm going to just show you how we go about setting the thing up. So let's just set a few things up. So first off, let's get our wafer and make sure it's correctly rotated. I'm just going to lift my probes, both of them up to separation height. Just give me a little bit of headroom. And I'm going to come and move my wafer up to contact. I'm going to turn off my autonomous. So I'm just going to disable it. And what I want to do is I just want to make first off that to make sure this wafer is aligned. Now, what I could do, if I got my probes, they're both, if you look down here, let's look at the status window. So if I do hide, I've probably got it somewhere I can't see it. Put it, it's probably in my second monitor. Yes, it is. Let me just view both monitors briefly. I'm operating remote of this machine, by the way. I'm in the UK. This machine's in Germany. And I can see my status. So all my position is X, Y. They're both at home positions right now. So I could basically retract my probes, and that way I can get them outside the field of view. So let's go and do that. Okay. The actual movement will be very small, so I don't actually need to do this. But it's... Oh, helps if I'm on the right setting. Let's move it back. That was the index mode. So let's go, and we're going to go the scope follow mode. And so I'm going to just drop the chuck. That way we're not having to do, move to contact and separate every time. I'm going to bring up my alignment, and we're going to do train auto align. And I'm going to use the current die size and recalculate it. I'm going to use that feature inside there. We're currently at 2x magnification on our A view, and we're using a 10x lens. So the system's just stepping around the wafer that extents and trying to make sure it's correctly aligned. Okay, we finished doing that. I'm now going to move my probes back to their home positions. No, in fact, let's not do that. Let's go and just double check our ISS is good also. So you'll notice that we're in focus on here at the moment. Let's move up to contact. And I think the scope follow mode turned itself off, but I'm going to move our EView back up towards contact height of 2000. So you can see it's 2000 down there. So I'm going to move to my cal site. And I'm going to move to separate and contact and home. Likewise, I'm going to do the same thing over here, so you can see that we are in focus. when it's at contact. If it wasn't, what I would have done is I would have cleared contact like this, and I would move this up and down to ensure that this is all the correct height with respect to where the chuck height was. You'll note that our scope hasn't moved in X or Y or Z. So now I'm going to do an alignment on the ISS. And what I'm going to do is switch on my scope follow mode, and again I'm just going to drop the chuck. And I'm going to use the automatic alignment, and it knows it's an ISS, so it's going to automatically move to the correct offsets and use the correct algorithm. The reason why I'm not looking directly at the camera is I have a large monitor over here, which is what I'm looking at preferably, so we're just using the camera on my laptop. Okay, so our ISS is being correctly aligned. For the purposes, even though we're going to be setting this up ourselves, well, let's go and make sure that our probes are on the correct spot. So I'm going to tell this probe to move into home. Doesn't need to be perfect, this just needs to be reasonably good. We'll move up to contact in a minute. Let's move this one to home. I'm happy to do this because I know where I just checked both at home before I did this work. Otherwise, I'll be moving very slowly. And now I'm just going to move the chuck to the align height. And I'm just going to and it's basically the eView is following that throughout the range. That's why it looked in focus all the time. So yeah, everything is good for that. I'm happy with everything. I'm just going to set these markers that you see right now. These are going to the line markers. If I can turn them off. I can also query from WinCal, and it uses the appropriate one. These markers, the blue line is the contact start, the green line is the contact stop. This outer red line is the outer edges of the reflect standards, and these are the inner edges of the reflect standards. So it's really good, particularly for manual probing. It gives you a view of how things are progressing. So let's go and set that to home. And you can see that the positioners are all home, so everything's great. I'm on location H, and I'm going to go to my system. I have my impedance standard substrate. It's already in WinCal. You could obviously add them, select the one you want to have. I'm going to use this one. I'm going to point to, by the way, this isn't so much a full WinCal setup, but I got here by going system. I have my VNA already set up. I can just look at stimulus, make sure it's what I want it to be. Typically looking for 100 Hertz. I'm going to get from the VNA, compare it. So everything's all matching. I can go to just check my station works. I can go to the speeds I want it to move at. I like to give it a little bit of time to stabilize before I start taking measurement, and I tend to move it more slowly. The position is I have my right hand one enabled just in case I want to do multi-line TRL. Probes, this is the probe types I'm using, and the pitch is particularly important because the pitch will be used for autonomous later on. And I got my standards, it's 104783, and we set the reference location H. Calibration. Autonomous will use whatever calibration algorithm we have set up. We have the LRRM calibration set up. We're currently set up to with a auto-load inductance calculation range of 0 to 120 gigahertz, and we're going to use enhanced auto-load inductance calculation. And what else to say? Validation. We're going to be using the automatic settings to validate with, which you see the behavior in here. If I turn this off, you'll see the behavior. So minus 5.1, minus 10 femtofarads on the capacitor. This post-correct reflect means it will be correcting using the open it measured during the cal. Monitoring is important because monitor is an integral part of autonomous RF, and we basically are going to be doing an open and air and comparing. And I'm going to say the EVM delta between the current measurement and the one during cal, the maximum it's allowed is to be within 3%. I actually deliberately make these statistical median things quite sloppy because I don't want it failing for that. Let's do that. And I can save that as, for instance, I'll put my desktop. This was a training I did. So this would be video. I'll call it that. So I can recall it if I want to, but my script when it runs will save this as different stuff anyway. So that's all good. And I could just do, often you might do a quick cal here just to make sure it works, but the system was all working a minute ago. I have in here, I have access to see what my VNA is up to, so you can see my VNA. And one check you can do is just maybe move to, just check everything all works for the load. Now I've used this location a fair bit, so you can see it's calibrated, so it should just fall off like a cliff. I've used this location quite a fair bit, so I'm going to just change it. You'll notice that I deliberately have locations set to be bad because I don't want them used. It's going to use the topmost, leftmost. I'm going to force it to use this one, and you should be checking against your map to make sure these are trimmed locations, or you could measure them using a B1500 or similar parametric instrument. Okay, so I'm going to use that site for my calibration when I run autonomous, so that all looks fine. Let's go back to our wafer site. And I'll move it to separate height, line, contact. So this is fine. I have one thing I should probably show you here is also how to set up the cleaning, automatic cleaning setup. So again, just in case I mess something up, I'm just going to whip my probes up. Let's just whiz them up here, a few hundred microns, get them out of the way. Same likewise, we'll just do this one, a few hundred microns. Nicely out of the way. And what I'm going to do on my E view is I'm just going to take its height a bit lower down when I do this, just so I'm away from that general region of probes being closer to the Fiducial I'm going to use. I'm going to move the focus stage to 1500. I could do the same thing by pressing the control key and using the scroll wheel on here. So let's say I move it to about that position. And if I go to the Velox settings, I can go to the oxides, and we have this thing called the cleaning manager. And in the cleaning manager, we determine how we're going to clean. So we're going to clean using Oxide 6, which is my pad cleaner. I'm going to give it 4 cycles of 800 milliseconds each with a 25 micron overdrive. So that's all been set up. The cleaning sites you can see in use, we're going to use site 6. It's got a line ox correction on, and we're going to use a reference site to find that when we're at temperature. So let's go and just go to setup. I'm going to open the cleaning setup manager, sorry, cleaning setup wizard. And I'm going to set this to say, yes, I want to do the clean. And we're going to use a line ox, rectangular. I'm going to retrain the reference just so you can see me do that, but often you don't need to do that. You can just update the Z heights if you've just changed, set up around to the new height. This is how big the fence is. And if I come up here, I've set this up before, so I can move up to separate height, but don't do that if you've done first time out, because you could damage your probe. So only do that if you're confident. If you're not confident, then you should, move slowly like this. So yeah, I'm in this region here. We're not going to focus on here, just so I know that it's physically present. And I have this fiducial marker. It's on the ox chuck fence, a distance away from my probes, so I can see it. The probes don't obscure it. And now it wants me to determine the size of my cleaning media. So this is saying I'm allowed to be within 500 microns from the edge when I do my automatic movements, and my automatic movements will be defined by the probe size in X and the probe size in Y. The idea is it's going to make a 50 micron step each time it moves horizontally, and a 300 micron step when it moves vertically to keep itself away from the detritus from the previous cleaning cycle. So I'm going to move to the top left corner. Again, I've set this up in advance so I can move to separate height, but don't do this if you're not confident that that's correct. I also have location set up in here. So for the top left corner, top right corner, and bottom right corner. So that determines the extent of how big the ISS is. We now go into vision mode in Velox, in Spectrum Vision. And now I basically, it's reliant on me being in focus at this point. So I'm going to move this down so I can see it really is nicely in focus. Sometimes a little bit hard to see with this medium, but it doesn't need to be perfect because the cleaning media is quite forgiving with regard to overdrive. So somewhere around there looks pretty decent. So I'm going to press next. I could use the autofocus, but I prefer not to. And now I'm going to go and find my reference site. So I'm going to move this up. It's basically cancelled my previous training for height. I think it's done this, for safety reasons. The E view is at 1400, so it's nice and away from our probes. And our probes are separated anyway. And I'm going to recognize this box down here. And you could change your illumination if you wanted to by pressing that corner. And now we're going to fish and move around the field of view. Sorry. Not going to move the field of view because I didn't tell it to. Okay, so we're not set, but the system's all trained up and ready to go with regard to the cleaning. Okay, so let's close the Velox settings. And I'm going to be back at home, so let's go back up. And then move up to contact. And I'm going to move my E view to home position. And I'm going to go up to 2x magnification. And we can see things align pretty nicely here. And what I'm going to do is move the probes towards contact. So I'll just take them to separate height, align height, and then I'm going to move the probe to the right point. I'll move this towards contact. This CM300 is using an ECX box, by the way. So that's contact set, so that's fine. Let's do the same for probe 2. Again, if you're not sure, don't ever just move straight to separate height if you've never set it up before. Mine is set up. That's pretty good. That's fairly well set. I'm going to set it to be current height. So that's all zeroed up. That's all pretty good. I could maybe adjust the focus a little bit. Not bad. Okay. So let's go. And one other thing I want to do is, so this wafer map, I haven't showed you the setting up of this, but essentially we have in our wafer map the ability to have different geometries of movement. So let's just move this to the point it lets me have the sidebar. There we go. And I'm going to show you the subdi definitions. So in subdi definitions, you can see these subsites, but each one of these has a position associated with the probe movement. And I can get to that by pressing this setup button, and I have used motorized position as enabled. So first off, I'm at the home location, everything's 0, so I'm going to update my home, which is really important. You don't want to forget that. And so now, if each one of these, if I show details, you'll see we have an associated offset of our motorized positioners. So this one has nothing because it's 1 picosecond. This one's 3 picosecond. So it's got 243 micron offset on my right-hand positioner. This one has a 685, and you see the associated stage offsets. Okay, so that's all set up and working. So I can just give it a little test, make sure we can move to this line. So this is a 7 picosecond line. So all working nicely. So I'll take this back to the reference position 0. Okay. So let's pull this down size-wise a bit. And we might choose to leave the sub-die open because we can see what that's up to. That's quite useful. Okay. So let's go and set up autonomous. So I'm going to press this, train autonomous, auto RF. And what we're trying to do is the system will want to know where the probes are to recreate the setup I've given it to already. So it's important that your probe placement is as you want. This part is all down to you. It's down to your probe placement. So you have a box, you put it around your probe. And it runs a focal scan. We're looking for a nice sharp peak, and we want our threshold ideally to be above any shoulders. Similarly for 2. And you can change shutters and illuminations and all those kinds of things in here. And we'll just say, yeah, we're looking for this region here. All good. So let's go to the wafer fiducial. And I'm going to use this shape here, which is in the middle, so we don't make any movement. But we could move to other fiducials like this one down here. This one does tend to work fairly well, but obviously it's important that it doesn't have anything too unique about it. It's got some stripes and things down there. Maybe not so keen on that. What else we got in nearby? Let's say this number 3. That doesn't look super unique. Got a bit of a spot there. Let's see what else we got. I like it to be fairly close by if we can. Why don't we go for this 1? That's quite nice. So let's do this. Doing it on the cuff here. So let's see what we've got. We don't want it too close to the edge of the probes. I mean, you could. There's nothing to stop you putting it up here, but typically I like this to be in the path 2 of the view. A little bit of a spot there. Let's see if we can get rid of that. Let's see if we run with that. The whole idea is that anything you find, it's going to be quite close to where the probes would be because it's looking so often. So it doesn't need to be super unique in the overall wafer, but it does need to be unique in the field of view where it would be normally. And if it's blocked by the probes, that's a problem too, but it will retract the probes if it has difficulty finding them. So it's now going to run the cleaning cycle based on what we just trained it with. You can see it's just a nice little touch on the probes. And again, I know I'm reasonably good, so I'm going to just bring up to straight up to separate height. But if you're not sure, you can bring it up slowly. And I could move that box if I wanted to. But in general, the nice thing about autonomous is every cycle you run it, it's going to be using what it was trained with before. So I'm going to be looking in this box here, and you could be adjusting this threshold. You want it to be nice, and so it's trying to isolate the Fiducial, the alignment mark that you're going to be using on the ISS. So it wants a threshold. Effectively, it's making it binary threshold. So everything brighter than a certain value is ISS alignment marker. Everything darker than that is not, and is ignored. And it's going to be using that to identify the centroid of this shape, and that sets the probe group. We have this offset value, which is how far we're going to move to one side to find clean alumina. So it's moving 300 by 300 in X and Y. And then we'll move around a grid of 6 possible positions if you have some issues. This number here is the tip spacing at contact. So this is like your 1 picosecond number that you have for the impedance on the substrate. And this is how much scrub you're going to use as you make contact with the probes. So if I press find probes, you can see we're finding probe tips well. If I have this set in some value like here, you see we find nothing. It'll just be garbage. It doesn't find anything at all. If it's even close, you'll see what you can sometimes see. It will find some sort of erroneous stuff going on. Though it actually seemed to do pretty well there, but it's best to make sure the tips look nice and clean with not too much noise and sparkly bits in them. That's great. So made contact. You can see a bit of contaminant there. Let's maybe move to another offset location, to another region of alumina where it's not so dirty. So that's good. So identify that. Yeah, that's fine. So now it's been trained, so it knows how to find the probes of contact and separate. And basically, it's now going to iterate the probe spacing and overdrive using the motorized positioners in order to get all the contacts good. So now we've set reference in place, and now WinCal is ready to calibrate. By the way, the one stage I didn't do was I didn't move these crosshairs bang onto where the position is. It drifted a little bit, but I didn't bother to reset it because it was close. But we could do that to improve how that looks visually. It also is looking for those crosshairs being not too close to one another because it uses that. It says, oh, it knows if something's gone wrong. So yeah, that's finished. That's our step. It's all our setup done. That's us finished our setup. So now, we can then go and check it out. Just check everything looks accurate. So we should be able to. I should be able to go in the wafer map and step to a new location. That's going to do optical correction from stepping from one site to another. Look for the probe spacing, probe over travel. Well, not over travel, just at probe position in space. He doesn't actually look for over travel, but it's there by virtue of the known offset from the fiducial to the reference location. Yeah, that works pretty nicely. And what else we can do is we can do AutoCal. Okay, so that's not all complete, and now I'm going to just move back to content, and what I can do is I'm going to just now start my testing. So I've got a script here, and this is simple demo script. It's going to go to 3 different temperatures: 25, 25, 75, and 125. And basically it's going to go through the sites 234, 234, 234. The idea is this gave flexibility, so you could select different subsites if you want to, but I'm just going to use the ones we've created on here. Let's maybe pick some different sites. Say what to skip, or maybe test these ones. So I've sort of started using things a little bit more. Let's do smart to probe. Probe. Skip. Smart to probe. Okay, so hopefully these an unprobed die, and hopefully we'll be working well. So I'm going to set this off to run. Let's just save our project. Everything's all trained up nicely. All this information saved in the project, and then we can kick off. We have in here the ability to automatically soak, so I'm actually going to have a really fixed, only going to have 20 minutes, just because at the moment we would ordinarily have this a lot longer, but we don't have this machine too much. We have to hand this over to another application. So I'm going to leave it just with, in fact, actually, I'm going to just give it pretty short. I'm going to leave it with 10 minutes. We're not spending very much on each die, so I'm not too worried about that. Okay, so let's kick it off. This script, by the way, will take measurements from WinCal as it goes. And what I'll probably do is do the next section from my measurements of debut, my video capture software down there, and I'll just speed them up, so hopefully make for a more interesting video.